Good afternoon, everybody. My name is Wilton. This is Pradipta. We are presenting an introduction to GitLab workflows, as Flo mentioned. And Georgiana helped create the slides, a lot of help. And yeah, that's it. So just a table of contents. We'll start talking a bit about Git, the fundamentals of Git, some of the basic building blocks and how it works underneath on Git. This part may be a bit basic to a number of you, but bear with me because it's going to be useful later on. Then we're going to go into Git history. It's many facets, and how understanding history and how that works is really helpful in having a good Git workflow and how that can really help your development or slow it down and make it worse. Then we're going to talk about GitLab functionalities, and some of its features that are built on top of Git and how that can also help and make your life easier. And then finally, we're going to give some general recommendations regarding both Git and GitLab. So first of all, we jump already into the Git fundamentals. Again, this part is very basic. What is Git? So it's a distributed version control system created to support software collaboration. So the idea is that you can have a number of different copies distributed over different places, and you can control the version of your software in a coherent way with all these different places where the software lies. It has a lot of tools to manage your software and its versions, and especially doing branches and concurrent versions, and also merging these branches to evolve your software. And these tools also support a number of different workflows. Some can be better, some can be worse. And our idea here is to show maybe how can you approach things so that things go better. And it facilitates both individual work when you're working on your own, but especially when you're working in a collaborative environment with more people developing software as a group. There are also GitLab, GitHub, Codeberg, a number of other platforms which are built on top of Git and provide additional functionality like project hosting, continuous integration, code review, many other things. And again, this is built on top of Git. So it's really good to understand the difference between what is Git functionality and what Git provides and what those other platforms provide, because they don't all provide the same things. There are some things which exist in common between them and some things that don't. And when you're working with multiple of them, it's good to have that in mind. So now that you have a kind of a vague picture of what Git is, most of you probably already know much better from before already, we can start to talk a bit on the building blocks of Git in terms of how it works. And for me personally, the three main ones are commits, history, and branches. And it's important to understand how that goes underneath Git, so to then understand how you can better use it. So very basically, a commit, as you all probably know, records an individual set of changes to the files, and it is identified by a hash. So all commits have a hash, and this hash summarizes the state of your repository in that particular point in time. Another important thing about commits is that all commits, except the first commit in your Git repository, all have a parent. Each commit knows its parent by the hash of the parent. And then another important thing when you think about parents from commits is that you can also think of a commit not only as a snapshot of your repository in a point in time, but also as a mini recipe of how you take your repository from one state to another state. And then also when you think about parents and children, you can think about like a family tree in a way. And basically that's in the end what history is, Git history is. So it's basically a family tree starting from the first commit that you have in your repository down to the last version of it. And then you have all these different paths and versions that somehow coexist. And then finally, a branch, which I think we all are somehow familiar with that, is just nothing but a pointer to a commit. So internally, Git works by simply having a file that's named main or that's named development. And inside of that file, you have the hash of a particular commit. So every time that you move from one branch to another, it's just updating which of the commits are in the current head. And that's really good because the branch names allow you to more easily navigate in the Git history and also allows you to more simply extend the history by adding new commits to that point. Then now, how do these concepts and how Git works with that function with the commands that you use from day to day? So the first part is cloning. So Git clone basically will create a local copy of a remote repository in your machine. This is usually a Git server like GitLab or GitHub, but it doesn't necessarily have to be. You can really clone a repository from your colleague's computer if you have access to that. Then you have, of course, commits, some of the commands that you probably already used, add and commit itself. So add stage status changes for a commit. And when you call git commit, what happens is that, of course, a new commit will be created, but internally, the parent will be marked as the current branch tip from where you're working, and it will update the branch pointer to this new commit, and then you have a small sum from the previous state that you had. And you have branches, again, when you type git branch, which is, let's say, the main command for creating branches, it will simply create a new file named for that branch that you want, pointing to the commit that you were there before. You have some other useful flags here, like cam to rename a branch, c to copy a branch, also with the ref log, which is a brief history of changes that happened in that branch, not the commits, like things that you did on that branch. And you have git switch, which is the new modern way of switching between branches. And then finally, you have some commands for managing these branches and integrating them, and also remote changes from repositories like fetch, pull, rebase, merge, and push. We'll talk about some of them later. And the idea of merging is that it integrates completed features from different branches and makes convergences between branches as well. So again, a lot of very basic stuff. You're probably all familiar with that. Now we go for practical terms, like how is an example of an everyday use of such commits and what's Git kind of doing in the background. So let's say that I'm working on some software and I have identified a bug and I want to fix that bug. So one way that I could do it is just start by cloning the repository for that fresh clone, create a new branch. Again, when I create a new branch named fixed, it will just create a new file pointing to the same commit as is currently in the tip of my main branch or master branch. And then I can switch to that branch fix, which will just update the head that I'm working on. And then I can actually fix that bug. So I do some changes, add them, commit them, and then I'll have a new set of commits added as ancestors from this, descendants from this common ancestor coming from main. And then eventually when I'm finished fixing that bug, I'll go back to main, update the main, which in this case doesn't have any new changes from the remote, and I can just call merge fix for Git, and then it will basically update or bring these new changes to my main branch, right? And here you can see that there are no additional merge commits created. That's an important point because the first thing the Git will try to do when you try to do a Git merge is the so-called fast forward merge. There are multiple types of merge, but that's really the default type of merge that Git will use whenever it's possible. And it's only possible when there's no divergence between the branch that I'm trying to merge and my target branch. And that divergence happens when my target branch or the tip of my target branch is not an ancestor from the tip of my source branch. And that happens, as you know, very often. And then what happens from the internal point of view of Git is that when you do a fast forward merge, actually there is no merge happening. What's happening is that since the main or the target is an ancestor from my source branch, Git will simply change that pointer, which is in the main, to my source branch. So there's actually no merge happening. It's just an update of that internal pointer to say that now the path that your target branch is taking is a different one. And therefore, there's no merge commit created. And that's usually a very clean way of doing a merge because, well, you don't have conflicts at all. But we know that in the real world, that's often not the case, and we are often faced with conflicts and problems. And so we can imagine a similar scenario based on what I told you before. So imagine that we had that same initial scenario, so main with 2 commits, and I was working on that fix, and at the same time, Pradipta actually thought about this great new feature to introduce, and he created a new branch called feature from the same base in main. And that's all fine. At that point, he starts working on it. He does 2, 3 commits, which are adding interesting functionality to my software. And eventually he finishes that feature and he wants to merge it back. But then we run into a problem because he'll go to the master branch or the main branch here, and we'll pull or fetch the updates, and we will have a conflict because now the changes that I introduced are on that branch. And as Git is taking the local timestamps of the commits, you'll see that all the commits are intertwined. And that's a problem because then we have divergent branches. And when Pradipta tries to do a merge, what will happen is that a new merge commit, additional merge commit will be created, tying these 2 diverging histories and solving all possible conflicts at this particular merge commit. And so this type of commit is the other one that Git can do, which is called a three-way merge. So Git will resort to a three-way merge whenever a fast-forward merge is not possible. And it's called a three-way merge because it will take this common ancestor between these two different histories and take the tips from the two branches that I'm trying to merge. It will take everything that's common in the two, leave it there, and take changes from each of them that can be added automatically, and things that conflict, it will hand over to you for you to solve whatever problem you have. And then it will, as I mentioned, create a new merge commit, which ties these two histories. And that new commit will have two parents, actually, not one. And on that merge commit, you can also solve all the conflicts that appear from this merge. And one very important thing that I really want to highlight here is that history is no longer linear. And I know that we haven't even touched in history in what linear history means. But in the next slides, I want to try to show you why not having linear history is actually a problem and can cause a lot of problems in your day-to-day work. And with that, we go to Git history, right? So first of all, we have some types of history and mishmashes between them. The history of a project can have, like, in certain periods, different parts of that. And these are not like textbook definitions, but they're widely kind of known in the development community. So the first one is linear history. It's pretty straightforward. Every commit has only one parent, which is its direct ancestor. And you have this, if you look at the master or the main branch, you'll see only that, right? A sequence of commits, quite nice. Then you have semi-linear histories, which is basically, the definition is kind of similar. So each commit has only one parent, each functional commits. But in between, you have this forced, let's say, merge commits whenever you join some changes. So here it could be like a section of bug fixes, a section of features. And when you merge it, you force it to have a merge commit to identify this particular set of commits as related to that feature. And this is, you can see this in a lot of cases when you're using GitLab to merge, for example, or GitHub, because it forces this merge request merge to exist when you do it. And finally, you have non-linear history, which is basically when you're using three-way merges and doing different forms of updates forward and backward, and then you end up with this case, right? And it is all looking at the main branch of a repository. So you clone it, you try to see the history from the main branch or the master, you'll end up with this that I'm showing you here in a visual way. And then now I want to tell you some of the benefits of having a linear or a semi-linear history in comparison to a non-linear one. So I brought the two figures here again for reference. And I think the first one, which is pretty clear, is that linear and semi-linear histories are usually cleaner and easier to understand than non-linear ones. I don't know about you, but I would much rather work on the first repository than on the second one. It's much easier to understand which features are coming in, when they're coming in, and yeah, the parts that they are entering is much easier to go through this history and understand what's actually happening. The context of all commits is preserved, and this is a bit of a harder picture to paint because when you're doing a three-way merge, again, it's just tying these two different diverging histories with this merge commit. So the context makes sense in this merge commit, but if you go back to one of these commits, which is either from one side of the history or the other one, it's only going to understand the context in the changes from that branch itself. So that branch doesn't have any clue about the other branch, which also can introduce changes in between. So you end up with a context that doesn't make sense for the future context when that merge branch is existing, for example. When you have a linear history, all commits can and should yield a stable state, which means that you can go back, you ideally can go back to any commit, and it's pretty clear where that stands in your history, and that ideally that commit stands on its own, let's say, and doesn't depend on anything else. Like, for example, when you have a three-way merge with two divergent histories, if you go back to one point, it doesn't really represent a final or an actual state, consistent state of your code. And then also searching and fixing for bugs is much easier using bisect, for example, which is a tool from Git that we'll talk a bit more later, because it does a binary search on your work. You can also do that when you have three-way merges and diverging ones, but it's much harder because you have to choose which side of the history you have to go through. So it's much more complicated. And then with this, at least this, there are, I think, even more reasons why having a semi-linear or linear history is good. But with this, I hope I convince you a bit of, like, at least the benefits of having this. But then you can tell me, well, I'm working with Icon, for example, and then there's hundreds of developers all working together, and they're all pushing, and of course there will always be conflicts. So there's no way of having a linear history. And then I tell you no, because Git rebase exists, and that's a really cool feature from Git, which basically allows you to always have a linear or a semi-linear history. It has its own catches, but I think it's really worth giving the benefits of linear and semi-linear histories. So what it does is basically it rewrites a sequence of commits instead of doing a merge, for example. It rewrites sequence of commits on top of a new base in comparison to the original one that it was. And then it's important to think of Git history more as a recipe and not as a work log. So it doesn't matter what time you committed, if you reverted the changes or all these smaller changes that you do. What matters is that a piece of history should represent a feature, recipe on how to, let's say, add a feature to a particular state, how to bring a repository from a state without that feature to a state with that feature. And then, of course, there can be conflicts, but they are solved for every new commit that Git is applying on top of that new base, which is a different way of thinking it again. So if we go back to the previous example that I mentioned, when Pradipta did his features and he wants now to merge it into the master, what will happen is if he does a rebase, Git will take each one of his commits and try to apply it on top of this new base. So instead of coming from main true, it will go to the fixed true and applying each of these commits. And if there is a conflict to that commit, it will be solved when that commit is applied. And you can think of it again as like, for each step of your recipe to get to that feature, you do some tweaks to make it make sense for this new initial state that is coming from. And then later on, you can call a normal merge and get a fast forward merge, as I showed you in the beginning, and or force a merge if you want a semi-linear history. And then there are some caution to be had with rebase because it can also be problematic in some cases. So the first thing is always to rebase children on parents. So you'll never rebase the master on your feature branch or your development branch on your feature branch. It's always the branch that you branched off on top of its parent. The commits are all rewritten, so you will lose commit hashes. So if you're somehow relying on existing commit hashes for certain feature branches, let's say, that won't work because you have new hashes. These new commits that are written, they will conflict with the hashes on the remote repositories. So you have divergent histories for your feature branches, let's say, and you have to force push these new commits to that new branch. And since force is a very dangerous operation because you're telling it to ignore your remote history and take mine as the true one, you should always use this force with lease, which will prevent accidental overrides when someone else updated the branch in between your rebase. And then, of course, another safety recommendation is that important shared branches like main and develop should always block force pushes. And ideally, in cases with a lot of shared development, also commits in general. So that's another topic also on its own. And then finally, just general recommendations on assuming you have linear. Go ahead. Who what?
So you said that the situation of push would be why.
So when let's say you have let's say you branch out from master, you did 5 new commits. In the meantime, the new master has 10 new commits. So you want to update your feature branch on top of the main, right? When you do the rebase, you have new commits on top of the main. And these commits will like your local history will diverge from your remote history, and you cannot conciliate them. That's why you have to force push to your remote repository.
If you already put the branch will not rebase.
Yes, exactly. Like, yeah. Yeah, then just recommendations. So the first one, it's really that long-lived branches are usually a problem. Either if you're doing rebase or if you're doing merge. If you have a 1-year-old branch with 200 commits or 20 commits with thousands of lines for each commit, that will always be a maintenance hassle, 99% of the cases. Then you can come to me and say, well, but I have to use long-lived branches because I have to develop this very large feature and I'm not working 100% on that, 100% of my time on that, so it will take more time and everything. And I say that in 95% of the cases, that's not really true, because when we think about one big feature, that's usually not one big feature. It's actually a collection of much smaller features that are somehow dependent on each other. So the first really important thing is identify the dependencies and how you can split your changes or features into their basic independent parts and then merge them separately. So for example, if you're thinking about introducing a new algorithm that depends on an external library, some of these separate tasks could be, for example, preparing the build system to receive this new library, then adding the library, then adding the files and the encapsulation for your algorithm, then adding the algorithm, and then doing some type of delayed wire up to actually get the algorithm into the main critical path of your work, for example. And this is a very important skill to develop to keep your branches short-lived. Make your individual changes stable. Again, in the sense of I'm splitting my big feature into smaller ones. How can I integrate that into the current working version without breaking it and making sure that everything is stable for every new addition that I do? Doing atomic commits, and that's one of the most important recommendations here, which is like your commits should do one thing and one thing only. So if you're updating your README and at the same time changing your build system, that's not an atomic commit, and that's a problem because atomic changes are reversible changes. So in this case, if your build system has a problem with your new commits, you also have a problem losing the changes on your README. So you should always think about like what's the shortest distance that I can go in the direction of the future and have that as a commit. Rebase frequently to reduce conflicts, because in my experience, at least, it's much better to rebase once or twice a week if you're working a lot in a repository than waiting for, I don't know, a month or two and then rebasing it all at once. When you're ready to merge, you will actually be able to merge in minutes. And finally, use automated tools. Test your code to make sure that your changes are stable. And if you're using GitLab or GitHub, use continuous integration to make sure that everything that's getting into your main or your upstream development branch is tested and working. And with that, I finish my part and I hand it over to Pradipta to talk about GitLab.
Yeah. Thank you, Wilton, for the nice overview of Git. So let's continue now. So now that we have explored the fundamentals of Git, and so we can now extend the idea of Git, the fundamentals of Git, and also the capabilities that it has towards a project management tool, which is GitLab. So GitLab is a cloud platform to for the developers that helps developer host, maintain, test, and then deploy their code. And so one can ask why GitLab only? So there are also GitHub and Bitbucket others, but we're talking mostly about GitLab because DKRZ hosts GitLab server, and that is possible because GitLab allows it to for someone else to host a GitLab UI in their server, and also it can be done for free, and also GitLab comes with integrated CI, continuous integration, and continuous deployment tools associated with it. So if I have to give some ideas of GitLab in a nutshell, so it adds some additional functionalities on top of Git, and here are some of them. Yeah, so on the left-hand side, so you can see that under the themes section, so there is a new concept called issues that is very much GitLab specific here, where the developer can start an issue to develop a new feature, and then the developer can also add the reviewer or some other person to review the code or to be part of the whole process. And so then everyone associated with this issue will always get notifications from GitLab whenever there are some changes made in the code associated with this issue. So I will talk in details about merge request, which is also an extension of Git merge in the context of GitLab. And there is also wiki, where it's kind of again an extended version of README, where there are more information about the repository can be found. So these branches and commits are still the concept from Git, but they are again the new concept pipelines, which has information about the GitLab CI, GitLab CI things. So if there is a GitLab repository. Now the next question is how to get the code from there. So one can clone the git clone to get the code from there, and so there are the links. If someone wants to get the code, someone wants to clone the code. There are two ways. The first is one can use HTTPS links by copying the link from here, but then the user needs to provide username and password, not only just for cloning, but also for later if the user or the developer wants to just pull or push for those cases, and also for icon if there are submodules like icon. So while updating the submodules, also one needs to provide the username and password. The better way is to use do the cloning using SSH, which would require SSH keys for extra security, of course. And there, GitLab needs to be authenticated via this SSH keys. But it's good that it needs to be done only once per development environment. So for a particular computer, and do it once. So for that, the steps are that first we need to generate an SSH key first, a local SSH keys that could be of different types. So that doesn't matter. And once to generate this SSH key, which is it is always beneficial to put a passphrase for better security. And again, the problem would then be to provide all the passphrase every time one needs to clone or pull or update the submodule. So that's why it's better if we could if we add the key into SSH agent by SSH add, so that make it passwordless or passphrase-less for each of the steps. And we can also associate. We also need to associate this private key to or the address of this private key into this SSH config file, so the system knows, the local system knows where to look for this private key. Once we have everything set up in our local environment, we just need to add this public key in GitLab by going to user, then preference, and SSH keys, and then adding this new SSH keys there. So there is a good, it's very nice documentation about the whole process on GitLab. One can just click on this link and get more about it. Now that we know how to clone a repository, now the question is which repository should we clone? The original one, or is there other possibilities available? And yes, and this is nothing. There is a Git fork, which is not inherent Git feature, but it's an additional feature for GitLab, where you can create a new repository, which is a copy of the main repository under your own namespace. And that is beneficial in cases like if you want to contribute to someone else's project, but you don't have the right access to directly push your changes there. So there you need to first get a fork, then you have all the right access, and then clone to your own system on local computer, and then make the changes, and then you create a merge request. I will come to that in a little while. And so there's one case where we need Git fork, but we can also start a new project based on an existing one, which doesn't need to be merged later to the original one. And there also it makes sense to create a Git fork. Okay, so now this is not a recommendation. You should not do that. You should not create a fork from icon and KIM. But if for any other project, you can create a fork by clicking this and then proceeding further from there. That's the way you can create a fork. So once you have created a fork and then cloned it, is essential then to sync your local repository or your own repository to the original repository. And you can do that by first, of course, you need to clone your own fork, and you will work on the repository. You make new comments there, but in the meantime, the main repository also has new comments, so you want to get it synced. To do that, first you have to add the original repository as a remote. We do that by this command git remote add, and upstream is a name for this remote original repository, and you just add to your git config. And then you fetch the upstream. So that's the original repository. And assuming you're working in your main branch, then you can mark your main branch or the changes coming from upstream main to your local main branch of your main branch to your own repository. And once you have to also then fix all the conflicts, and once this is done, you can locally or you can push the changes to your original, to your own repository, the fork repository. And once everything is done, then you can create a merge request to merge your changes to the original repository. That's how the workflow goes here. So now there are two ways, of course. So as Wilton also mentioned, so you can create a new branch, a feature branch from the original repository, work there, and then merge it. Or you can create a fork and create a branch in your fork, or you can work also on the main repository there, the main branch there, and later you merge your fork to the original repository. And which one is better? So there is also, it depends on what you want, right? So you can use a fork when, as I mentioned, you want to contribute to a project, but you don't have the right access. Or you want to start something new from an existing code base that you don't necessarily want to merge back. So in those cases, you can use fork. But in all the other cases, it's always recommended to use a branch. I mean, if you have, you're part of internal development and have all the access as a member, then it's always make more sense to use a branch instead of create a fork and in that way. And also, if you are working on a feature branch that you want to merge back, of course, that has to be a local branch to the original repository. And also, if you want to maintain a different version of software, then you definitely need to have it as a branch to the original repository. Okay, so now we'll mention a bit more about the other features of GitLab. The first thing is the continuous integration that Wilton already mentioned. So whenever there are some some developer is working on some new feature, it's very much possible that she will introduce a bug. And for that, we need to test the code thoroughly using unit tests and functional tests. And that can be done using this GitLab CI framework. So this as an example, so this is actually where we are using build.runner runner to start this test on different server. This is an admin specific thing, but one can also use the runners that GitLab has. So in another project, so these are mostly unit tests, or not even unit tests, these are for linting, and these are build test to build the code, to check the building of the code, and then also related to documentation and deployment of the documentation. So, and these page are known, are called pipelines. So pipelines then show you all the tests that is done through CI. And to run a billboard, one can also do it manually, but for GitLab CI, the tests are run whenever new comments are pushed into GitLab. Okay, so another feature, very important one, is the merge request. So here we take the concept of git merge, but we put it in a context of several developers working together. So there, if someone want to introduce something new section of code, I think it's always better that it goes through a review process, a thorough review process. And merge request is that process. So one can create a new merge request, which includes, of course, a title, and a brief description about what exactly it contains, what are the changes made in the process, and also it should include a reviewer to review the code. And to do that, to create a new merge request, one just need to go first to the repository via code and the repository, and then one needs to create this merge request. And that's very pretty straightforward. And then goes to this box, and here one is to just give the title and the description, as I mentioned before, and then create this merge request. And once this is created, it will show this merge request will show all the comments associated with this new branch that is going to be merged into master. It will show all the status of the pipelines, which contains all the GitLab CI results. It shows that everything is passed, except for some which are skipped, which is the good news. And when the development is done, all the pipelines are passed, then the reviewer will go and look into the changes and see if everything is fine there or according to the coding panel and like it was. And there, if the reviewer doesn't like something, so then he or she can put a particular comment on depending on where it is. So one can also put comments on each line or in a particular line. So that's really a very nice user interface to work with for reviewing code. But it can also happen. So that rebase is required. This merge, the reviewing process is longer in a lot of cases, and the master merge will definitely go ahead, will continue growing, and there it will happen that the source branch is 8 comments behind like this, compared to the target branch. So GitLab also provides this nice user interface to do the rebasing here. So it will start the rebasing. There will be conflicts, can be conflicts, and which could also be fixed through this process. So these are the main part of GitLab that we will now use to give you further recommendations and to introduce you with the workflows that one can use for smoother work, everyday work. So we have talked about most of the tools, but there are a few tools that we can still recommend. One of this is Git Bicep that Wilton has already talked about. So this is a binary search through commits to find a bug. And this actually has very much helpful, very helpful to get debugging process following the history. Then there is the cherry pick where one branch can cherry pick certain comments from another branch instead of having everything together as a merge. That's also a very good tool to introduce only only part of the changes done in another branch into your own branch. And there are other tools which can be used to see this graphical history viewers along with the differences in each comment. The one I showed you in it as a change log in changes made in a particular merge request in a GitLab UI can also be seen by using GitK or GitG. So you can also find documentation to link into this document into this slides. And then Meld is another visual diff tool, which helps to find differences between two branches. So, and I personally find it really helpful when I do rebasing. And there I use a different method. It's quantum meld to make sure that I do not introduce a new bug while doing this rebasing. And then there are different plugins that makes Emacs or VS Code users life easier. There are many Git and GitLab plugins for this, which are also recommended. Now there are some best practices that we would also like to implement. First, for branches. So as Wilton also mentioned, that it always makes sense to have branches which has one functionality or as simple functionality as possible. And that would make the branch a short-lived one and also the total merge request smaller, which helps the review process. And there are some naming convention suggestions for branches. So if you are trying to create a new feature, then you name your branch starting with the name of the word feature. If you want to fix a bug, then start with bug fix. Or if it is a branch that you exactly don't know where it's going, but you want to keep on working, so there you can start with your username as the branch name. And of course, you should. If it is going through a merge request, the branch will be deleted. Otherwise, please delete the branch when the changes were merged in one way or another. And for comments, I think some of it is already covered by Wilton earlier. And so, but this is very useful, very much useful that you should always compile before you commit some part of the code. And keep comments atomic. Of course, it's already mentioned by Wilton. And then there will be some locally generated files. Please don't add or stage those files into Git repository. Instead, declare them as inside PDF node so that it would never come, it will never show itself when you do a Git status. And also, don't afraid of committing too much. There's no such thing. So you can always save your work by doing a commit. And again, if you are doing atomic commits, then that should not be any problem as well. And then please try to be precise about in your commit message, and except for a few cases where, of course, in the merge request, there has to be a detailed comment or description about the total commit. Otherwise, try to be precise about it. One can use a different pre-commit hooks also to make the comments more sanitized, like beautifier for Fortran or C++. So that would be one example for that. And for many more different several recommendations, so like this conventional commits gives you more recommendation about how to write a commit message, and their semantic version also gives you a recommendation about how to come up with the versioning for a commit message. So finally, we'll talk about the total workflow that we suggest here. Of course, we talked about the GitLab issue. That's where it all starts. Should all start. So you start with the GitLab issue. You can assign it to yourself or people you know that want to work on this issue. Which, assuming that you already have a clone of the repository, then you create a branch. Then you develop everything in the new branch. You commit everything, and when it's done, or even before that, you can open a merge request and ask for the code review when all the pipelines are passed and you are done with the development. And when there will be need of rebasing the branch, and you also need to solve conflicts and fix them. And then if everything is fine, then you merge the branch into main. The branch will be deleted, and then at the end, you will close the GitLab. So that's all from us. And thank you for the attention.